All right, so next one is graphical summaries of data. And we start with 2.1, and these are the objectives. Number one, construct a frequency distributions for qualitative data, construct bar graphs, and then construct pie charts. All right, first, two definitions here. If you need to copy this, copy now. So the frequency of a category is the number of times it occurs in the data set. A frequency distribution is a table that presents the frequency for each category. All right, so let's start with an example here. A retailer accepts 4 types of credit cards and lists the types used by the last 50 customers as follows. So based on this data, so we're talking about qualitative data. So these are the different credit cards. How many different credit cards do you see?
3.
3. What are those?
4.
4.
4. Oh, yeah, I think 4.
4. All right. So there are 4. So what we do is we have to tally all this. So let's say, for example, so those 4 are, so let's say Visa, American Express, and MasterCard, and Discover. So what you usually do is count the number of Visa cards, count the number of American Express cards, count the number of MasterCards, and the Discover cards. So that's going to be your frequency F. The frequency is the number of each card. So you know how to tally, right? Or you can just count how many Visas, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on and so forth. And on the next slide, you'll see the tally here, all the frequencies. So copy this. So we have a total of MasterCard 11, Visa 23, American Express 9, and Discover cards 7. So this is our frequency distribution about the type of credit card. So 11, 23, 9, and 7. Okay. The next one is relative frequency. So after you get all the frequency, all the Fs, next is how do we get the relative frequency? So that is a proportion of observations in a category. So if we get the formula for RF, or relative frequency, that is the frequency over the sum of all the frequencies. So take note of the formula. RF is equal to F over N. All right. So to get relative frequency of the different types of credit cards, so earlier I showed you we have 11, 23, 9, and 7. So since the formula for RF is F over N, N is the total number. So here, get the total of these frequency. So add, oops, sorry. So add all this, and 11 plus 23 plus 9 plus 7 is equal to 50. So now to get the relative frequency, each frequency divided by the total n. So remember RF is equal to F over N. So that's why here 11 over 50, which is equal to 0.22. Next 23 over 50, then 9 over 50, and then 7 over 50. Any questions? All right. So that's how you get RF. And then after you get F and RF, we'll be able to use those data to construct bar graphs. So copy this definition of bar graph. It's a graphical representation of a frequency distribution. And it consists of rectangles of equal width. And the heights represent the frequencies or the relative frequencies. So let's try to construct a bar graph. So we have 4 different types of cards. So the first one, MasterCard. The second one, Visa. The third, American Express. And the fourth, Discover. And remember, the y-axis, the vertical line, should be your frequency. And remember from the last example, the total frequency is 50, or so just to recall, MasterCard 11, Visa 23, American Express 9, and Discover is 7. So highest here is 23. So we should have up to 23 here, or if you don't want to use by ones, you can have 5 by 5s, 5, 10, 15, 20, 25. And then use rectangles. So MasterCard 11. So let's see this. Oops. It's a different color. So let's say this is 11. Then Visa is 23. And then American Express 9. Discover 7. So this is your bar graph. Any questions? So it's the same thing if this is a frequency graph. It's the same thing if you use the relative frequencies. So earlier we got the RFs. Oops. So 11, what is the relative frequency of MasterCard again?
Point 46.
Point
0.22.
22.
Then the next one, 0.46.
46.
Yep, this one,
0.18.
0.18, and this one, point.
14.
Very good. So all you have to do is, if you create a different one, so highest is 0.46. Maybe I should just erase all this. So you can create a bar graph using RFs. So again, so let's say this is MasterCard, Visa, American Express, and Discover. And your RF highest is 0.46. So let's say 1, 2, 3, 4, 5. So let's say 0.10, 0.20, 0.30, 0.40, 0.50. So this is your RF. So MasterCard, 0.22. So let's say this is 0.22, then 0.46, and then 0.18, and then 0.14. So this is the bar graph using RF. And if you notice it, they are exactly the same as using the frequencies, same shape of the bar graphs, the bars. Okay. Questions?
None.
This is actually the graphs of those two. So the blue one, this is using by frequency, and the other one is the relative frequency. So like what I said, they exactly have the same bars using F and or RF. Next one is Pareto chart. If you want to copy this, it is desirable to construct a bar graph in which the categories are presented in order of relative frequency. And we have that as a Pareto chart, meaning it's in order from highest to lowest. So you just have to rearrange your bars. Since your highest is Visa, next one is MasterCard with 11, American Express 9, and Discover 7. So that is what we call the Pareto chart. It's the most frequently occurring categories. Next one, horizontal bars. We started with those bar graphs with vertical bars. You can also, if you want, you can interchange your X and Y axis. So instead of the vertical line using the numbers, you can use also the horizontal line. So you can rewrite it using horizontal bars. So here's is an example: employment of U.S. residents, farming, forestry, fishing, manufacturing, up to managerial, sales and office, and other services. Also, there's another type of bar graphs. This is what you call the side-by-side bar graph. And this is an example. So let's say monthly active users, if you are comparing data, let's say between 2 years, 2015 and 2016. So if you want to combine those in one bar graph to show the difference between the 2 years, so with two different colors, so 2015 and blue one, 2016. Most commonly used for side-by-side bar graphs are, let's say if you compare this male and female. So a lot of those are using side-by-side bar graph. So based on this data, most commonly used, I think this is for social media, is by that time is Facebook. Okay. Any questions about those different types of bar graphs? Let me know if you have any questions or if you think it's too fast, and let me know if I need to slow down, okay? All right, next one is constructing pie charts. Most of us know about pie chart, right? So if you want to copy the definition, it's an alternative to the bar graph for displaying the relative frequency information. So let's say you have the different types of cards again here, and you know how to compute the RF, the relative frequency. We did that earlier, 0.22, 0.46, 0.18, and 0.14. So instead of using bars, you can use a pie chart, a circle divide with using these percentages: 22%, 46%, 18%, and 14%. Oh, that's actually the whole 2.1. Make sure that you know how to construct frequency and RF. What's RF again?
Relative frequency.
What's the formula for RF?
Frequency over sum of frequencies.
Yes, thank you. And you're gonna need this also for the next sections. So we use this frequency and relative frequency to construct bar graphs, Pareto charts, or even a side-by-side graph. And RF also for pie charts. Okay. Next one, 2.2 are frequency distributions and their graphs. And these are the objectives. Even though 2.1 is really short, 2.2 is a little longer. So first, construct frequency distributions for quantitative data. So earlier, if you notice, we talk about qualitative data. So 2.2, we're gonna construct frequency distributions for quantitative data. And then instead of bar graphs, we're gonna use histograms. And then also the different shape of distribution from a histogram. This is very important for the next chapters. And lastly, we have the other two graphs, frequency polygons and ogives. All right, so let's start with frequency distributions for quantitative data. Okay, to summarize quantitative data, we use a frequency distribution just like those for qualitative data, just like what we did earlier. You saw that there are 4 different types of cards, and then we get the frequencies of each card. So this time, uh, since the data has no natural categories, we don't know, it's not like different types of cards, it's only numbers. So we divide those numbers into classes. Numbers because we're talking about quantitative data. Just like an example here on the right side. So you divide your numbers into different classes. Here, 1, 2, 3, 4. There are 4 different classes here. And classes are intervals of equal width from 0 to 4. How many numbers from 0 to 4?
5.
5. You can count 0, 1, 2, 3, 4. So there are 5 numbers. From 5 to 9, there are 5. From 10 to 14, there are 5. From 15 to 19, there are 5. So everything, you should always have this. That's what you call the class width, or CW. Here, the class width is equal to 5. And each class should have the same class width. Okay, so take note of that. Or if you don't want to count like what I did, 0, 1, 2, 3, 4, all you have to do is, by the way, the left side is what you call the lower limits. The right side numbers are what you call the upper class limits. So to get the class width, the easiest way to get the class width is subtract the first 2 consecutive numbers, or any 2 consecutive numbers. 5 minus 0 is 5. 19 minus 4 is 5. Or 15 minus 10 is 5. Or 14 minus 9 is 5. Or 9 minus 4 is 5. So any 2 consecutive numbers, you should have the same number, and that is your class width. Okay? So that's the easiest way to get the class width. Sorry about my voice. All right, so we have some guidelines for choosing classes. So there are many ways to construct frequency distribution, and they will differ depending on the classes chosen. So following our guidelines for choosing those classes. So every observation must fall into one of the classes. The classes must not overlap. The classes must not be of equal width. There must be no gaps between classes. Even if there are no observations in a class, it must be included in the frequency distribution. And I will show you all this next. And oh, I want you to copy this. This is important. Constructing a frequency distribution. Copy all the steps, 1 to 5. Yes. Come here. And let me know when you're done. All right, so step one, you can choose a class width. And then step two, this is very important. So choose a lower class limit for the first class. And this should be a convenient number that is slightly, less than the minimum data value. Convenient number that is slightly less than the minimum data value. Step number three, compute the lower limit for the second class by just adding the class width to the lower limit of the first class. Then compute the lower limits for each of the remaining classes. And you only stop when the largest data value is included in the class. Then count the number of observations in each class and construct the frequency distribution. All right. Can I go to the next one?
Yes.
Yes. Okay. So let's say you have an example like this. So the emissions for 65 vehicles in units of grams of particles per gallon of fuel are given, and you're going to construct a frequency distribution using a class width of 1. So by the way, most of the problems class width is given, or expect for any tests or quiz that I give you, I will always give a class width. Okay, so now look at these numbers, 65 vehicles with all these numbers here. How are you going to arrange this in a frequency distribution table? So step number one, we already have a class width of 1. Then step number 2 is choose a lower class limit that is a very convenient number that's slightly less than the minimum data value. So meaning, take a look at all the 65 numbers here. Which one is the lowest here? So that is the minimum value. Which one is the lowest?
Is it 0.25?
Yes, here, so 0.25. And which one is the highest? The maximum value?
Five point nine four or 6.
6.55.
Someone said
6.64.
6.64. Where's that? Oh, this one. Is this one? All right, so take note, the lowest is 0.25, highest is 6.64. So if you're gonna go back again, show you step number 2, choose the lower class limit, then this should be a convenient number that is slightly less than the minimum data. So minimum is 0.25. So choose a number, a very convenient that is slightly less than this. So remember, your class width is equal to 1. So when you do that, it's easier to choose 0, slightly less than your lowest. Your lowest is 0.25, so slightly less than is 0. So that's why class limit, or CL, you will start with 0, because even though your lowest is 0.25, so slightly less than that, it's going to be easier to use if it's 0. If you want to use 0.5, that's also fine. It's up to you, but it's gonna be easier if it's 0. And then your class width, remember your class width is equal to 1. All you have to do is add 1 to 0. So 0 plus 1 is 1. 1 plus 1 is 2, 3. Yeah, 4, 5, and so on and so forth. And your highest is 6.64. Since we have 2 decimals here, so that's why we should have 2 decimals also here, sorry. And you will only stop until you get 6.64. So this is 6 and 6 up to 6.99. So this is going to be your last class. So this is the lower limits. 0, 1, 2, 3, 4, 5, 6. This is the lower limit. And the right side is the upper limit. And remember, it should not overlap. So 0.0 up to since you have 2 decimals here, what is the number before 1.0?
0.99.
Very good. It's going to be 0.99. Here, next one is 1.99. Or since you know the class width is 1, after you get the very first one, you just have to add 1. 0.99 plus 1 is 1.99 plus 1 plus 1 plus 1 plus 1 and plus 1. See, you can your highest value is 6.64. That is between, you will see that in between 6 and 6.94, right? So this is your class limits. You have all the same class width of 1. And how many classes? 1, 2, 3, 4, 5, 6, 7. And there are 7 classes. Questions so far?
Yes. Why is the last one 0.94 and not 99 if they all have to be the
That's
same
9.
width?
That's 9.
Oh, gotcha. Okay.
Yeah, it's my handwriting.
Oh, okay.
It's just so hard to write on the screen.
That makes sense.
Yeah, sorry. What if I ask you, let's say, what is the upper limit of the 4th class? What is the answer? Upper,
3.99.
very good. So 4th limit, 1, 2, 3, 4, and that is the upper limit. Okay. So let's say what is the lower limit of the 3rd class?
2.
2. So 1st, 2nd, 3rd class, the lower limit, the left side is lower, upper, the right side numbers are the upper limits. Okay, very good. Now you have the class limits. Now you'll be able to tally all those numbers, all those 65 numbers, just like what we did for 4 different types of cards. Next is the frequency. How many of those numbers are between 0 and 0.99? How many of those numbers are between 3 to 3.99 and between 6 and 6.99? And you will see here, these are the frequencies. So usually what you do is you tally all those numbers. So if you go back to those 65 numbers, if you count how many numbers from 0 to 0.99 to 1, 2, 3, 4, 5, 6, 7, 8, 9, something like that. So this one, this is 2, this 1, 2, 3, and so on and so forth. And then the total, you just have to count everything, and that's going to be your frequency. And don't worry, I'm not going to ask you during quizzes or tests to tally all those, because I don't want you to spend a lot of time just to tally the numbers, because if you don't get the correct numbers, then everything's going to be wrong. Okay? So I'm just showing you how to get the frequencies. So here you should have a total of whatever your n is. You should have a total of 65 because you have 65 vehicles. Okay. And now after we get a frequency, you will be able to get RF. So you know also how, you already know how to get RF. That is F over N. So here we know that the total N is 65. So you can just, to get these numbers here, so that is 9 out of 65, you'll get this. So 26 out of 65, 11 out of 65. Okay, so that's how you get the relative frequency. So sometimes it's better to use 3 decimals, or if you use 2 decimals, when you add all this, the perfect one, you should get 1.00, meaning 100%, or it's acceptable even if you get 1.001, or if your answer is 0.9999, that is also acceptable. It's because of the rounding off numbers. Any questions? Any questions? All right, so I guess no questions. So now after you get the frequency and relative frequency, you'll be able to graph this, just like what we did earlier for qualitative data. So after we get the frequency and the RF, we'll be able to use bar graphs. So this time, with quantitative data, we're going to use histograms. So histogram is constructed by drawing a rectangle for each class, just like the bar graphs. The heights of the rectangles are equal to the frequencies or the relative frequencies, and the widths are equal to the class width. So, so this is the exact example of this table here. The class width, remember, from 0 up to 6.99, and we have the frequencies 9, 26, 11, 13, 3, 1, 2, and the corresponding relative frequency. So 9, 26, 11, 13, we have this. So the first one is 9 here, this is 26, and this is 11, this is 13, this is 3, this is 1, and this is 2. So these are all the frequency F. And if you use the relative frequency, you're going to have exactly the same thing with all those RFs. So if you notice also here, the x-axis is the lower limits. So you start with 0, 1, 2, 3, 4, 5, 6, 7. They all have the same equal width of 1. Your class width is equal to 1. So from 0 to 1 is 1. From 1 to 2 is 1. Everything here is 1. Okay, so you will see this on the test. Make sure that you remember histogram. The x-axis is the lower limits, and the y-axis is either frequency or relative frequency. All right, so choosing the number of classes. There are no hard and fast rules for choosing the number of classes. In general, it is good to have more classes rather than fewer, but it is also good to have reasonably large frequencies in some of the classes. And there are two principles that can guide the choice. So take note of this. Too few classes produce a histogram lacking in detail, but also too many classes produce a histogram with too much detail so that the main features of the data are obscured. And these are those examples: too many and too few. So look at this. Too many, the JAG experience distracts from the overall shape of the data. And this one is an example of too few. Only the most basic features of the data are visible. And there are also other types of frequency distribution, which is what we call the open-ended, just like an example here. This is a frequency distribution presents the number of deaths in the US to pneumonia in a recent year of various age groups. So they tallied age 5 to 14, there are 69 deaths, 45 to 54, 1,872. And if you notice, the very last class is 85 and older. Oops. So meaning the last class is an open-ended class. Because unlike this, the other classes, you only have the class width here is, what's the class width here? How do you get a class width again?
10.
10, because you can just subtract any numbers, any two consecutive numbers, right? Like 54 minus 44 or 24 minus 14, or just the first two. 15 minus 5 is equal to 10. So you know that based on these classes here, 1, 2, 3, 4, 5, 6, 7, 8, the first 8 classes, the class width is equal to 10. But the very last class is not 10. It's open-ended, 85 and older. So this is what you call the open-ended classes. And histograms for discrete data. So when data are discrete, we can construct a frequency distribution in which each possible value of the variable forms a class. So the following table in histogram presents the results of a hypothetical survey in which 1,000 adult women were asked how many children they had. So remember, let's say when you take a survey, how many children they had, you only want to get the discrete data, discrete meaning countable. So you can count using 1,000 adults. You do not use the different classes from 0 to 1 or 0 to 2, because you want to get the number of children, how many per. So let's say 0, 1, or 8 children, up to 8 children. As you can see here, out of 1,000, 0 is 435, 4 children, 38, 7 is 0, and 8 is 2. So you can use that as your histograms. Next one is after you get a histogram, now we can determine the shape of the distribution. What is that shape we're talking about? So there are some commonly observed shapes, terminology that we're going to use now, but we're gonna talk about this for the later chapters. Symmetric, if you need to copy this, if you, let's say this is your histogram, and if you have like a bell shape like this, then that is what you call symmetric. So a histogram is symmetric if its right half is mirrored image of its left half. So there are very few histograms that are perfectly symmetric, but many are approximately symmetric. So there's a lot of problems that are approximately not perfect. It's not perfect bell-shaped curve. If it's perfect, then that is that's going to be in chapter 7. Also, there are histograms with long right hand tail, like this one. It's not a bell-shaped curve. It's like this. It's a long right hand tail. And this is what you call the skewed to the right or positively skewed. And also you will see a histogram with a long left hand tail. So like this one. Oops, sorry. And this is what you call the skewed to the left or negatively skewed. So if I were you copy, make sure that you know all the 3 different shapes of a data set. Again, approximately symmetric or just symmetric, then skewed to the right and skewed to the left. Any questions so far?
Do we only need to memorize skewed to the left and right, or both of them, the skewed to the right or positively skewed?
It's up to you.
Okay.
Both are acceptable. Yeah.
Okay.
So just for you to be familiar, let's say if you read other statistics books, so let's say you only see positively skewed, but you know that it's skewed to the right, because some other books use skewed to the left or negatively skewed, something like that.
Okay.
And you can see on that based on the shape, if you have a long tail to the right that's positively skewed, then long tail to the left, because everything to the left is negative. All right, so also we have unimodal and bimodal histograms. So a peak or high point of a histogram is referred to as a mode. A histogram is unimodal like this, if it has one mode, and then bimodal if you have like this. So this is very timely about like the COVID-19, the virus, because we always want, it's like each country, did we reach already the top, the peak or not? Or are we gonna have a second? I hope not. Okay, and the last part is constructing a frequency polygons and ogives, and we're using our frequency distribution table. So earlier you learned about the class limits and the frequency, how to get those. Now we're gonna add one column for frequency these polygons and another column for ogives to graph these two. So like what I just mentioned, for frequency polygon, you need the class midpoint. So if I were you copy this, that is the average between the 2 limits. Remember, you have 2 consecutive limits. So lower limit for a class and lower limit of the next class, then divided by 2. So class midpoint, or other books use, instead of writing class midpoint, they use X. So we can use that, or just midpoint. So lower limit for class plus lower limit of next class divided by 2. So the average of those two. So just like an example here. So earlier we got our class limits. These are the class limits. And then to get a class midpoint, add these two numbers and divide it by 2. So 0 plus 1, then divide by 2 is 0.5. So that's why you have 0.5 here. Okay, so what I always do, take note of this, I do not compute every class midpoint. So after I get the first one, what is the class width again here?
One.
1. You know how to get a class width, right? Yes. So that's the difference between any limits. Let's see, subtract this 2, or 6 minus 5 is 1. Everything is 1. So after you solve for the first class midpoint, you just have to use your class width. 0.5 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 up to the last one. Easy, right? You don't need to show the computations like this. Just think that you just have to use the first two limits, lower limits. 0 plus 1 divided by 2 is 0.5. Then whatever your class width is, just add it to the next one. 0.5 plus 1 up to the last class. Questions? Again, be careful with the class width. All you have to do, subtract any two consecutive limits. Upper limits, if you subtract this 2 is 1. Lower limits is if you subtract this 2 is 1. Okay, everything is 1. All right, so next one is you will be able now to construct a frequency polygon. So that is constructed by plotting a point for each class. So this is very important, take note of the frequencies here. That is your y-axis, and the x-axis is your class midpoint. So remember earlier for histogram, we have the lower limits and the frequency, or the RF. For frequency polygon, you have to use the class midpoint and the frequency. That's why we computed the class midpoint. So that's why you started with your first class midpoint is 0.5, then 1.5 up to the last one, 6.5. And then you just have to use points. At 0.5, your frequency is 9, and then 26, and then 11, 13, 3, 1, 2. And then you just have to connect the dots by using straight lines. Okay. By the way, I'm gonna add something, because you will see this in most statistics books. What do you mean by polygon? What is a polygon?
Multi-sides. Multi-sided.
Multi-sided. What else? Is a square a polygon? Yes or no? Is this a polygon?
Yes.
Yes. Is a triangle a polygon?
Yes.
Yes. Is this a polygon?
Yeah.
So what is a polygon? How about this? Is this a polygon?
Yes. Yes, it's a polygon.
This is not a polygon. Why not?
It's not a closed shape.
Not a closed shape. So a polygon is a closed figure, it's a closed shape. So that's why a lot
I
of
thought you
books,
messed up drawing again on the computer again.
huh?
I thought you had messed up drawing on the computer again.
Oh no. All right. So that's why look at this, our red graph here. So a lot of books, to make it a polygon, we need to close this to make it a closed figure. So that's why even though these are your class midpoint, you're gonna need to add one to the left and one to the right. So since your class width here is 1, so 0.5 minus 1 is negative 0.5 here. And if you add 0.5 here, it's going to be 7.5. And then you can close it here to make it a polygon. Okay, so a lot of books you will see this, but for this one, since they didn't mention about it, so I will accept this without the orange. Maybe you will see this also on your Connect Math homework, so meaning you don't need to add another one and subtract another one. I'm just showing it to you, okay? All right, so that is a frequency polygon. So don't forget, is your x-axis is the class midpoint and your y-axis is the frequency. Next one and the last part, next type is the cumulative frequency. So you're gonna add another column here. So cumulative frequency is the sum of the frequencies of that class and all the previous classes. And for me, this is the easiest. So you have the frequency. To get cumulative frequency or CF, you always start with the first, whatever your first F is, write it down here. So it's 9. And then next, to get the next one is 9 plus 26 is 35. Then add the next number. So 35 plus 11 is 46. Then add the next number. 46 plus 13 is 59. Plus 3 is 62. Plus 1 is 63. Plus 2 is 65. And take note of this. Since you know that we're talking about the 65 vehicles here, so your total N is 65, or when you add these numbers is 65, right? So your very last number here should equal to your N. If this number is not equal to this, meaning there's something wrong with your addition here, so do it again. Okay, so again, your first number should be the first number here. And your last number should be your total N. So 9 plus 26 plus 11 plus 13 plus 3 plus 1 plus 2. So that is your cumulative frequency. Any questions? All right, so we need to use a cumulative frequency to graph the next one, which is what you call the ogive. So ogive, not ogive. So for ogive, you use cumulative frequency as your y-axis. So CF is your y-axis, and then your y-axis is the upper limit. So remember, for your histogram, we use the lower limit and the frequency, or RF. For ogive, you use the upper limit and the cumulative frequency, CF. So let's say upper limit, the first cumulative frequency is 9. So here it's 9, then 35, then 46, then 59, 62, 63, and 65. And then again, just use a straight line from point to point. And that is your cumulative frequency. Any questions? Questions?
None.
And that's the last part of 2.2. All right. Since we're done, I need to show you. I'll show you another example. This is from the book, and you'll see something like this for your tests, especially the test 1. So let's say, given this is from the book number 29, time spent playing video games, the number of hours given the class limits. So if you want to copy this, can see given 25, 34, 48, 29, 23, 17, 13, 7, 3, 1. So given here, this is the time spent playing the video games. So these are your class limits. So remember, for class limits, the left side, the left numbers are the lower limits, and the right numbers are the upper limits. So you have the frequency F. And if we want to construct everything that we discussed for 2.2, so meaning to complete the frequency distribution table, maybe let's have RF too. RF. Next, you need a class midpoint X and the cumulative frequency CF. So first, So expect something like this on the test. You will see a given class limits and frequency. You're gonna compute. You're gonna complete the table. Okay, so RF. How do we solve for RF again?
Frequency over sum of all frequencies.
Yes. Thank you. And N is, if you count all this, it's gonna be 200. Okay. So now we're going to compute for RF. $25 divided by 200 is 0.125. So I want you to do the same thing. Complete this table for RF. Okay, so these are your relative frequencies. Next one, X, or class midpoint. How do we get the class midpoints?
You add the lower limit class and the lower limit of the next class and divide it by 2.
Yes, so these two numbers here, 1, so X is the class midpoint. So 1.0 plus 4.0 divided by 2 is what's the answer?
2.5.
2.5. So that is your first class midpoint, 2.5. And then next is, remember, I don't want you to compute each time for the class midpoint. So what do we need to use?
We need to add the class width.
The class width, yeah. So now what is the class width? Based on the table, what is the class width?
3.
3. 4 minus 1 is 3, or any numbers between two consecutive lower limits or two consecutive upper limits is equal to 3. So you just have to add 3 here. So 2.5 plus 3, 5.5, 8.5, 11.5, 14.5. Okay. Any questions? Next one, CF. Do you remember how to get the cumulative frequency? How do we start?
You start with the 25,
Start with the very first F, so which is 25.
and then you
And then-
add the 34.
The 25 plus 34 is 59. Add the next one, 107. Add the next one, 136. The next one, 159. The next one, 176. The next one, 189. The next one, 196 plus 3, 199, and plus 1, 200. So meaning this is correct because the very last number is equal to your total n, 200. All right, so any questions? All right, so also last part. Oh no, what happened? Can you still see the table?
Yes.
Yes, all right, perfect. Let's see, the last one is just to remind how to graph using this data here. So the first one, histogram. What you need to remember is the X and Y axis. So what to use for histogram? What's the X axis to use for histogram?
The x-axis is the class.
The class, and which one?
Lower limits.
The lower limits, so meaning the left side. So you're gonna have 1 here, then 4, and then 7, up to 31, after the last one. Okay, so you only need to use the lower limits, and then your y-axis is either frequency or you can use RF because you're gonna have the same shape. Next one, the frequency polygon. So what do we need to use here? What's your x-axis?
Class midpoint.
The class midpoint x, very good. And you have your frequency here. And the last one is the ogive. What's the x-axis?
Upper limit.
Yes, the upper limit. And this one is?
Cumulative frequency.
Very good. Cumulative frequency. So remember all those, especially for the graphs, those X and Y axes, that's very important. Don't mix any of those. And make sure that you know how to complete the table. So whenever you have the F, RF, X, and cumulative frequency. Any questions?
None.
Are you copying this?
I have a question about the some of the questions at the back of the book that I was doing, that I was working on. There was one question that had one of the histogram bars that was missing, and it asked how to find what the information was. How would you do that?
What kind of histogram? Did they use frequency or relative frequency?
It was...
So there are two types. If you're talking about, look at this, the histogram here is either frequency or relative frequency, right?
Yeah.
So if it's relative frequency, and let's say you have the table, and let's say, good question. Let's say you have missing this. What's that missing relative frequency? So we know that the total of RF is, what's the total? It should be 100%. So it's, if you have 3 decimals, so 1.000. So meaning you can add all these numbers and subtract it from 1. And that's going to be your answer here.
Okay.
So if you add all these numbers and if you subtract it from 1, it's going to be 0.145. Okay.
Okay.
Or if you're using frequency, so let's say this one is missing 13. So you know that it should be given, you know that your n is 200. So all you have to do is add all these numbers and subtract it from 200, you will get 13.
Okay.
Okay?
Yeah, thank you.
Yeah, no problem. Any other questions? If you don't have any questions, can I erase all this now?
Yes.
Yes. Or if you want, you can, this is recorded, you can go back and watch it again. And